CloudDB, shaping your new normal.
Welcome everyone to the 2021 APEC Groundbreakers Virtual Tour by Apaco UC. This year our event will be the biggest one ever done with 144 sessions, including normal sessions, workshops, and hands-on labs, from 100 different speakers over 17 days. Also, it will cover sessions in 4 different languages. Please remember to register to as many sessions as you can. That way you'll be able to watch the replays of the sessions up to December 30. I would like to say thanks to our Oracle user groups and Java user groups that made this event possible, and also to our sponsors, Oracle Groundbreakers, and your main sponsor, CloudDB. Now for today's session, Anti-Money Laundering Using Graph Convolutional Network by Bhupendra. Please feel free to use the chat window or live webinar on the right lower corner of your screen if you have any questions, and Bhupendra will be answering all your questions at the end of the session. If you have any issues during this session, please feel free also to let me know by using the same chat window. Without any more further ado, let me leave you with this amazing session by Bhupendra. Bhupendra, the room is yours.
Yeah, thank you. So very good afternoon, good morning, good evening, whosoever connected from across the world. And thanks for joining. So I'm just going to talk about anti-money laundering using graph-based technology. So that's the topic which I'm going to cover. So overall, I'm going to cover all these points under this particular topics. What is the anti-money? What is a money laundering? Right? So what are the different processes we have in current FSI sectors, right? Financial institutions. And because of this money laundering, what is the impact on the financial institutions? What exactly business problem of financial institutions are going through with the money laundering issues? And then my research is actually trying to hit a couple of problems, which is actually very important on the financial institutions perspective. So, and then then I'll talk about motivation behind graph technology, why I picked up the graph technology behind my research for this particular topic. And also I'll try to introduce, various tools and technology and, methodology I'm going through to actually counter this particular problem. So these are the points I'm trying to cover. Feel free to ask if you have any further questions. So as mentioned, so I'll try to handle your questions at the end of the session. All right, so here we go. Who am I, right? So I'm working as analytics practice lead for Oracle ASEAN, and also I'm doing my research in anti-money laundering. So, and at the same time, I'm trying to get my hands dirty with the neurotechnology as well, because the graph technology is a very interesting area, which is actually I'm trying to fit into both anti-money laundering as well as neurotechnology. And also I'm a founder of mathematics community, which is known as tensors.co.in. So you can reach out and you can, if you wanted to join the community. So this community is pretty much dedicated for the mathematician across the world who wanted to, collaborate on the novel area of the mathematics. And we all know even data science and machine learning, even graph technology is nothing but mathematics. So that's the whole objective. I'm trying to create a platform where I can actually provide opportunity to cross collaborate on the mathematics side. So now money laundering, right? So what is actually money laundering? So basically, if you go with the definitions, right, money laundering is in the generic term. So whatever the illicit income you have earned from the various sources, you're trying to make it legal money, right? That's the very one line definition of the money laundering. But if you go very the technical definition of money laundering, so this is actually various stages of money launderer is going through to do all these kind of money laundering activities. So if you look at there are 4 layers, which is actually called placements, layering, and integration, which is nothing justification, and integration, investment, right? So what does it mean, right? So I'll try to give some idea, right, exactly in the technical terms how it has been defined in the and money laundering community. So like I mentioned, whatever monies you have it's being earned from the illicit sources, which is not properly coming from a proper channel, be it a tax crime, maybe somebody is trying to hide the taxes from the government, doing some kind of fraud, and some drug activity, theft, bribery, corruption, all these illicit money earned from the different illicit sources. And eventually these money is actually not legal money, somehow going through with this different layer. This money is trying to be justified as a legal money. So idea of the placements here, right? So all these money is actually being divided, being distributed and deposited into on a different mode of the cash transactions, sometimes cash deposits, sometimes changing the different kind of denominations. So that's the how money earned from illicit sources being placed across a different channel. And then further uh, uh, those money is going to be bring into the digital system of the financial institution by doing a different type of online transaction, or maybe withdrawing cash from the bank, and then distributing all those money into different accounts. So then further these money is going to be utilized to show as an justify these are the legal money. How they can try to justify, for example, they will try to show, okay, they have some financial loss and they are trying to subsidize those financial loss in the business. And they got some they sold some property. So from all these, that is how they're trying to justify the money. And final objective of those money is to make it legal, and then invest it legally into different kind of system, buying money, buy lands, property, and cars, or different kind of investment. So that is the whole idea to actually going through with this process. All money is going to be translated as a legal money, right? So that is the money laundering in an overview mode. So now if you look at the what is the process we have in financial institutions to actually capture all these kind of money laundering activities, right? So what happens in financial institutions like bank, they have transaction monitoring systems already in place, right? So whatever the transaction is going through, passing through the bank's digital mode, which is actually generating some sort of a SAR reports. It's called suspicious account reports, right? Idea behind this is actually rule-based engine generated, and which is actually trying to monitor the transaction which is going through the bank, and if there is a transaction which is actually crossing threshold, and then that's where this suspicious account reports is actually getting generated, right? So and then further this SAR is actually passing through a different kind of machine learning model. Sometimes it's a pretty straightforward rule based engine, and sometimes even organizations are using machine learning model. So they are definitely giving trying to create a risk score against all suspicious account reports which is generated by transaction monitoring system. And then this risk score is actually varying from 0 to 100, where 100 is the highest risk score. So and then it's depend on organizations to organizations. They have created their categories, what is the range of highest risk score, maybe 80 to 100%, medium is 40 to 80, and then low is 40 to 0 to 40%. So idea is to actually find out what is the highest risk account which is actually probably engaged into money laundering activities, right? So based on these machine learning models, then the backend team get into activated whatever the reports generated over here. Backend team is start engaging the operational guys to try to find out or verify whether this is a really case of the money laundering or not. So how do they have a different kind of systems, mechanisms. Sometimes they call to customer, sometimes they verify complete account details, how this account is flowing from which source to which destination, what is the amount, what is the pattern, that all these kind of exercise they do in the behind to finally clarify whether this could be a really case of money laundering or not. And based on those exercise, they then finally prioritize what case should be prioritized to further go with the proceedings. Proceedings means of course all financial institutions has to submit this kind of reports to central bank on a day-to-day basis, right, as an further investigation, right? So then central bank and with the joint collaboration with the banks, they try to find out and investigate whether this is a really case of money laundering or not by collecting all necessary proofs. And then they start with the criminal proceedings if case is proven it's a money laundering case. That is how the current process we have within the uh, financial institutions. So but we talked about money laundering, we talked about what is the current process we have, right? Within this process, following the slides, I'll try to explain what is the gap we have with the current process, right? The why it's motivated me to pick up this topic, right, to actually try to find out and fill the gap with my solutions. But before that, let's try to understand, if there is a money laundering happening, what is the impact of all those money laundering on the financial institutions, right? Each and every country has their own central bank, and they have set some sort of national and international regulations to cater this kind of money laundering activities, right, counter this kind of money laundering activities. So it money laundering activities is actually having a huge financial impact and also social impact. So it is very obvious for each and every government or country to have a proper rules and regulations in place to counter this kind of problem, right? Because it's not only financial impact but also social impact is there, right? So that's why it's very obvious, right? So uh, uh, I like and overall, if you see, the money laundering activities is actually contributing around 2 to 5% of the global GDP, right? And each and every year, this kind of there are cases being reported and investigated and being penalized, right? So here, if you look at, there is a one very famous case in Malaysia. It's called 1MDB, right? So this case is a very famous case in money laundering activities. Because of these, there are various parties was involved into this activity, and later on it was investigated and found, and a case is being filed. I'll just try to highlight a couple of financial institutions who was actually engaged into this money laundering activity, and eventually they had to settle this case with the Malaysia government by paying this kind of a huge financial, huge penalty or fine, right? For example, Goldman Sachs, they paid $3 billion to Malaysia government, Deloitte $80 million, AM Bank $700 million. So I have attached all these references any point of time wanted to look into, right? These are the very published news. So I have quoted from there. So idea is, if you look at, right, so knowingly, unknowingly, the case has been happened within the banking system, and then and it impacted heavily on this financial institution in terms of the brand, in terms of the financial losses as well. So it makes very obvious to have a very stringent policies and regulations which is equipped with the latest technology, latest to counter all these kind of problems, right, related to money laundering, right? So I would like to recommend one of the very interesting book which is actually written by Tom Wright and Bradley Hope on this exactly same 1MDB case, right? It's called $1 Billion Whale. If you get a time, please definitely read this book. Then you can get a complete picture how people are playing in the world with different money laundering activities, right? So very nice, well defined, very much story craft, very nicely story crafted in this book, and it's worth to read if you're really interested about money laundering, right? So Yeah. Now, we talked about what is the current system we have within financial systems, right? So that is in general, right? Probably a couple of a few organizations are way ahead with this system, but in general, that is how this systems we have within the financial institutions to actually counter this kind of money laundering, transaction and activities. So eventually, they have the systems available, but because of the technology innovation and all, nowadays we know we are even it's earlier we were playing we were actually in the long back it was actually a currency based money laundering activities. Now because of technology digitalization come into picture, then the net banking and all these digital banking into place, so that's all digital technologies being used for money laundering activities. And further we know with the evolution of cryptocurrencies, right, people believe it's a really secure and all, even though in the cryptocurrencies there are heavy engagements of money laundering activities are going, right? So where is the problem, right? Even advancement of the technology having lots of policies and regulation in place, however there are huge money laundering activities are happening still, right? As I quoted previous slide, it's a 2 to 5% of the overall world GDP, right, which is a huge amount, right? So those systems are placed even though there is a problem because there is a gap in the systems or process and regulations, right? So if you look at in general, I'm trying to highlight, I try to create some picture in front of you how this entire money laundering process happening in the financial institutions. But what is the problem, right? Problem is actually with these systems, right, lots of high false positive rates are getting generated, right? So false positive rate, how it is impacting. So false positive rate is nothing but the transactions which is not actually money laundering, it's also been notified or generated as a money laundering activities. Eventually you're getting huge list of transactions which is actually alerted or notified as a money laundering activities. So what happens because of this problem, right? So eventually there is a backend team engaged to verify whether this is a money laundering activities or not. So impact is like your operational team is actually heavily engaged to verify this. So it means your operation cost is increasing. At the same time you have issues with the negative customer sentiments. So how negative customer sentiments? It means when cases come into picture and ops team in backend, they are verifying each and every cases. They sometimes call to customer and to verify all these transaction details, and then customer get annoyed. Why I'm getting call? Though I'm doing legal activities, however bank is monitoring my each and every transaction and asking so many questions. So that kind of a negative sentiments gets generated because of high false positive rate. And there is also false negative alerts. It means the transactions which is actually a money laundering transaction, but because of this rule based or different kind of machine learning based transaction systems applied within the anti money laundering process, they are missed to actually capture those transactions which is still a kind of money laundering activity. For example, in bank, right, if you have 1,000, you have set some rule within your transaction monitoring system. Let's take an example. You have set rule of if transaction is beyond $1,000, right, then the system will generate alert as a suspicious account report, right? So but a person who's a money launderer, they are smart enough, they try to change their pattern of transaction. So they start sending transaction with the value of $999, which is just $1 left with the $1,000. So it means they are still doing all these legit transaction, which is probably a money laundering, but your system is not able to capture because your threshold is actually $1,000, right? So that's how it actually miss to all monitor all those even transactions, which could be a case of money laundering activities. And the other problem statement, right, because of this rule based system. Sometimes they have applied machine learning logic also, but we know a rule based problem we just discussed, right? If your threshold is just $1,000, so eventually your $999 is absolutely passing through without any issues. But at the same time, when you have a machine learning based model applied, so we all know there is a data drift issue, right? So over the period, your machine learning model's performance gets deteriorated because it's not continuously getting updated with the new features. And over the period, your money launderers change their pattern of transaction. It means whatever the features you have applied in your machine learning to do classification of transactions, which is no more valid because the data drift problem, because the money launderer had changed their pattern of transactions, right? So your system or machine learning model is not able to find those a new pattern. So that's where this is actually a gap, we can say, with the current process and system. And at the same time, there is a huge manual process actually engaged to verify whether this case is or suspicious account reports generated is a case of money laundering or not, right? So sometimes ops team go with the their own judgment, right? Their so that judgment could be a bias because of human errors, right? So all these kind of a problem is still there, and eventually that is where the money launderer managed to get all these gaps and try to do further money laundering within the being even within the system, right? So these are the very important problem which is actually still being faced by financial institution, due even though have a very uh, uh, nice process or technology being adopted, or they started from rule based engine to machine learning based model to counter all these, though there are still a big gap to actually not able to exactly identify all those cases of the money laundering activities. And eventually we all know, because of if banking or a financial institution missed to report all those money laundering cases to the central bank or a regulatory, then they are liable to pay a huge penalty because of this money laundering happening within their ecosystem. So it's very important to address those problems so that this fine, penalties, brand impact, all those can be avoided, right? So my research objective is, right, how to fill these gaps in the current system, right? So how I can actually reduce the high false positive rates, right? So that eventually it can save a huge operational cost. So that is the very very straight and very direct impact on the overall costing perspective. And how I can actually even capture those alerts or those money laundering activity which was actually missed by transaction monitoring system, right? By using that's another my objective in this research. And at the same time, with by doing this research, I'm trying to solve the data drift problem. It means, like I mentioned, right, money launderer are very smart, right? They change their pattern of the transactions, and how to identify those pattern on a regular basis. If patterns are getting changes, if managed to get those patterns, that those patterns can be used as a feature engineering technique, and those new features can be further applied to your machine learning classification model to give a better accuracy of your current machine learning model is already in place. So that is the how I'm trying to solve with this data drift problem on a continuous basis to identify the right set of features which can be used to train my machine learning model, right? And overall, my objective is to actually try to come up with the new AML kind of anti-money laundering framework, which is comprised of the graph-based technology, and then also I'm trying to do some findings towards the regulatory provisions what we have within the national and international boundaries, right? So at least if we can actually further give some sort of a feedbacks to central bank, I mean these are the regulatory provisions which is already there, how it can be further improvised so that we have a better control on these money laundering activities, right? So, so you just heard about, graph technology. I'm trying to use the graph technology in anti-money laundering. But what is the motivation behind this graph technology in anti-money laundering? So you have seen here, I try to show, the trend of the graph is being used in, AI and machine learning based use cases. If you look at the trend right here from 2016 hours, steep curve. It's if you look at the trend of graph technology being used in along with the AI and machine learning is really increasing in a very steep straight curve, right? So, and this is one of the graph, one of the report published by the Gartners. So, which actually stating graph is actually already proven a very promising technology to fit into various field of research, right? Various field of studies, right? So like I mentioned, I have chosen as an anti-money laundering for the graph based technology, whereas it's not limited to anti-money laundering. People are using across different segment, right? So for example, there is a huge uh, 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 prospects of the graph based technology in the pharmaceuticals, right? You recently have heard deep mind, which is actually managed to find the which actually managed to predict the right set of protein correlations, right? Within the DNA sequencing. So this is one of the very, so far it provide a very accurate information using that's again based on the graph based technology. And if you look at the Google entire day in day out, we are using Google Maps, right? So within the Google Maps, it's nothing but one big set of the graph being used, which is actually helping us to find the shortest path and maybe right path to reach a particular place, right? So that's how graph is being used, even from pharmaceuticals to map and spatial based technology and science and even neurotechnology. I talked about neurotechnology is again one of the very interesting area. I'm trying to explore how this graph based technology can be fit into. So this graph is actually being increasingly actually being adopted across the industries, right? No industry is nowadays untouched with this graph based technology. This is actually it's a very much complement to your AI and machine learning based research that people are trying to do, right? So, so graph, you look at the graph, right? We all know graph is actually collection of edges and edges and vertices, right? So this is what actually defined as a vertex, and this is defined as a edge, right? So how this association and linkage is happening between different vertices, and what kind of associations we have. So using this graph-based technology, there can be a different label of predictions can be done. One you can do at the graph level predictions, and another we can do as a link level predictions, and even you can do a node level prediction in case of the anti-money laundering, right? So whether so graph level prediction, how does it reflect to my anti-money laundering context, right? So by utilizing this kind of a platform and technology, objective is to find whether this entire set of communities is engaged into any kind of money laundering activities or not, right? So by monitoring their transaction pattern, this entire set of community can be predicted as a money laundering community or not. When it comes to link level predictions, if transaction is happening back and forth, it can be predicted whether this transaction is a money laundering transaction or not. And then node level prediction is nothing but which we are trying to say, okay, this particular account is actually engaged in any kind of money laundering activity or not. So this is a different level of prediction we can do, and that is what I'm trying to do in case of the anti-money laundering using graph-based technology. So okay, just all right. So when it comes to, I'll try to emphasize a couple of research paper which is already published into this direction. One is actually very interesting research paper. I have given a link here, so in case if required I can share the slide so you guys can actually go through with this. But the objective of this research paper is actually find the money laundering activity, do some forensic analysis of all cryptocurrencies transactions, right? So they have used the graph based technology. So it's not there within the graph based, right? You have a multiple level of analysis, right? So like analytics perspective, we have a descriptive analytics, predictive analytics, and prescriptive analytics. And same goes to graph based technology. In a graph based technology, we have a descriptive analytics where various kind of graph visualization is being used, right? And then it goes to predictive analytics where your machine learning models is being used within the graph based framework, right? So when this research paper is actually talking about, when they are using standard machine learning model to predict any kind of transaction or account as a money laundering activity, right? So if you look at the performance of this machine learning model is based on the different type of techniques being used. It's a varying, right? But when it is being used graph based technology, which is called graph convolutional network, it is a graph deep neural, you can say it's a graph deep neural network, graph based neural network, right? Deep neural networks, which is called graph convolutional network. So the performance has been increased across the model, right? So that's the whole idea. They are trying to actually so how this graph based technology is actually being a very promising, even in case of anti-money laundering, to classify correctly whether this particular transaction is a money laundering transaction and or not. They try to infuse logistic regression and random forest kind of techniques within the graph framework using node embedding methodology. So eventually all those has outperformed, and result was very good compared to standard machine learning model. So my idea is to take it to further to next level, where I'm trying to actually fit further trying to improvise further random forest kind of technique within the graph convolutional network and increase the performance of classification model, whether this transaction is anti-money laundering or not. So idea to increase this performance means, if you look at the problem statement earlier, talk about how we can reduce this false positive rate, false negative rate, how we can control, and eventually this has the direct impact on financial kind of impact, right? If you are trying to increase the if I manage to increase the accuracy of my model, so eventually I'm reducing the burden on the operational team, which is actually doing heavy lifting work to validate each and every transactions generated by transaction monitoring system. At the same time, they are going to investigate only those cases which is high likely a case of the money laundering activity. It means you're not calling to a legal or a loyal customer for a different kind of inquiry, which is as a process of anti-money laundering. It means you're trying to control sentiments of your customer as well. At the same time, you're submitting very accurate reports to central bank as in terms of money laundering suspicious account reports, so the central bank can also do a due diligence. And eventually you're trying to save your organizations by not missing any kind of money laundering transaction, which can cause big financial impact on your in your organization. Right. There is another paper published, which is actually this is a base paper I'm trying to utilize as a part of the graph technology base, which is actually calling about semi-supervised classification with the graph convolutional network. And I'm not sure what is the time. Let me quickly check about the time. So I think 10-15 minutes more left. So let me quickly cover and we can discuss if you have any questions. So this is another paper I'm trying to actually leverage, but basically on the graph convolutional network side. And another very interesting paper, right? So we know graph as a technology, when you're dealing with the millions and billions of transactions, when you have to process using the graph-based technology, how scalable graph-based platform you can develop, right? So how your deep learning graph convolutional network can perform better to deal with the millions and billions of transactions. If you think about China and India kind of countries, they are having billions and billions of transactions because of the population, right? So you definitely require a good set of a platform, and platform is not only very related to your hardware system or play or software system. Your techniques is also playing a very critical role, right, to perform, to give a better performance overall. So my focus is also how I can make a little improvement into a scalability perspective. So that's where I have taken a reference of this particular research paper, right? Further, what are the tools and methodology I'm trying to use? If you look at machine learning model, I'm not even leaving, right? I can, like I mentioned, your graph-based technology can very well coexist with your machine learning model and AI model, right? So it is a complementary. It's not a it's not a kind of a competition, but it can complement and can further improvise and improve your machine learning and AI based predictions, right? So definitely I'm trying to use all these different classification techniques, further have a comparative analysis in terms of performance, how graph a neural network, convolutional network is actually giving a better picture. And then I'll start first with the descriptive analytics by just doing graph modeling, and then on top of that I'm trying to visualize all those transactions, right? And then further I'm trying to use graph-based machine learning models, which is PageRank, to vector, all these different kind of machine learning model, graph-based ML, graph-based algorithm available. And at the same time, my focus is purely on the graph convolutional network, graph-based deep learning method. But the platform perspective, I'm trying to leverage Oracle Graph, right? So we all know Oracle database is a converged data base which can actually support graph, spatial, and JSON, all different even relational, all different kind of data types it can support, and it has a very good performance in terms of. At the same time, I'm trying to analyze other platform in terms of research perspective. For example, Neo4j, Tiger Graph, and then overall objective is to come up with the new AML framework which can actually support, which is comprised with the graph-based technology, and various steps actually being taken throughout this journey, right? So we'll start with all transaction monitoring, suspicious account reports generated by transaction monitoring system, which is available in relational data model, and eventually it has to be converted in the graph data model, and then do different kind of graph visualizations, try to find different type of graph. It's go with the graph feature engineering, try to find the right set of uh, features which can actually further embed it into graph convolutional network, and then finally execute a machine graph deep learning model to come up with the better accuracy. So across these stages, I'm going through with the various process and procedures to actually have a comparative analysis, right? So this is again one of the process flow, just trying to highlight how it is going to with the in my previous slide what I talked about, uh, converting graph data model, then doing visualizations, then doing different kind of graph query analysis, and then finally using those features engineering patterns to solve the data drift problem, applying the machine learning model, and then further utilize graph convolutional network to do all these classification model to better predict money laundering activities, right? So I have been trying to get realistic data from the different financial institutions, so that it can impact my research in a better way. But eventually, if you look at but it's very hard to find realistic data from the financial institutions, because there are lots of confidentiality engaged over there. However, but my research is not limited. There are folks in the research community, they have already done some fantastic job, and they have generated some simulators which can actually exactly generate. They have created a simulators which call AML sim, pay sim, which can exactly generate, the similar kind of data which is actually being generated by various transaction banking and transaction monitoring system within the financial institutions. So yeah, I'm trying to utilize all those database, for my research perspective. And there are, a couple of organizations who is already engaged in this kind of research, and they are publishing time to time different set of data. That's also I'm trying to leverage. So yeah, platform perspective, I already talked about, right? What are the very interesting things which I would like to highlight within the graph, deep learning, right? There is another very interesting work has been done by the, open source community. They have created a graph gym, right? So graph gym is nothing but a platform to design and evaluate your graph neural network based model, right? It's a very interesting. I'm trying to leverage, that is the whole idea, how my graph neural network, which is actually created for the anti-money laundering activities, how it is performing better than the previous model, what previous work has been done by other research folks. And that's how conclude my presentation. If you have any questions, feel free to ask. All right.
Hi,
So
Bhupendra. Thank you so much. Yes, I don't see any questions at the moment. If anyone has any questions, please feel free to post in the chat window. I don't see anything coming from the live webinar or the Facebook. Yep, I can see you're adding your email. Fantastic.
yeah,
If you have any questions watching the replays or that we will have all the replays of the sessions up to December 30 available in the platform, or you did not want to ask in the chat, or want to ask Bhupendra directly, please email him as an email on the screen, and he will be answering our questions that you have without any problem. Saying that, Bhupendra, thank you so much for taking the time to present to the community around Asia Pacific and around the globe. Thank you so much for doing that during our weekend. And please have a wonderful weekend. And please take care and be safe.
Yeah, thanks, Frankos. So it was wonderful experience to actually come here and present. So I would be very happy if folks, you are interested to know more about all these, feel free to reach out to me on my email ID. And happy reading and happy presentation. Enjoy your weekend. Thanks.
Thank you so much, Bhupendra. Have a wonderful afternoon. Bye-bye.
CloudDB, shaping your new normal.